So we're going to have a look at question 8 from the 2018 Leaving Cert Ordinary Level Paper 1. This is a question about functions and graphs, but there's also some calculus involved, some differentiation where we have to find the rate of change of this function. So what's the function about? Well, we're given a function c of t is equal to minus t cubed plus 4.5t squared plus 54t. And what this function does is it tells us the amount of drug in a bloodstream a number of hours after we've taken the drug. So if we enter a number of hours between 0 and 9 hours after taking this medicinal drug, the function will tell us the units of the drug left in our bloodstream. The first part of the question asks us to find the amount of the drug that's left in our bloodstream 4 hours after the drug has been taken. So we're going to write down the function. We're going to sub in t is equal to 4. T stands for time. We want to sub in 4 hours. And we tidy it up to give us that the amount of drug in our bloodstream 4 hours after taking the drug is 224 units. Now, we were given that in the question, but when they tell us to show an answer is true, we don't actually use that answer in the question. We want to actually just work through the question had we not been given that answer, and then we just confirm it by, when we get 224 units, we look up and we say, well, that's what they said it was going to be, and we know that we've got that part of the question right, and we can move on. So 10 marks for getting that. The second part of the question is to find the units of drug in the bloodstream after 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9 hours. So all the hours from 0 to 9. Now remember, we've already done how much of the drug was in the system after 4 hours. That's 224 units. And they've also given the amount of drug after 0 hours, which is 0 units, which we would expect. 0 hours after taking the drug, we've not yet taken the drug, so there'll be none of the drug in our bloodstream. And then after 1 hour, they've told us that there's 57.5 units of the drug left in our bloodstream. Sometimes they give you a couple of answers so that you can see what method you would use to find the rest, and then just check it with 0, 1 and 4 and make sure that the method that you're using does indeed give you that amount of units for each of those hours. So we're going to find the number of units after 2, 3, 5, 6, 7, 8 and 9 hours. The best way to do this is to draw a table. On the left hand side of the table, we're going to have all the inputs, so that's the hours from 0 to 9. We're going to input them one at a time into the function, and then we get the outputs, which is the amount of drug in your system. And then it's a good idea just to pair those up as a pair of points. Generally, there's going to be a graphing aspect to the question after this, and you just pair the input, which is the time, the number of hours, and the output, which is the amount of the drug. It's a good idea to check all of these points on your calculator. So there is a table mode on most calculators where you can enter the function. You won't have a t on your calculator, but you can enter x's. And you want to start at 0, you want to end at 9, and your step is going to be 1. So people who have used the table mode in the calculator will know what that refers to. Just fill in the table then, so by placing all of the output values here up, so 2 is 118, 3 is 175.5, 5 is 257.5, 6 is 270, 7 is 255.5, 8 is 208, and 9 is 121.5. And at this stage we can get a feel for what's going on in the question. We've taken a medicinal drug. The amount of drug in our system has increased up until about 6 hours, and then after 6 hours the amount of drug in our system seems to be decreasing again. And so it's a good idea to make a story for yourself as to what's going on in the question. It'll make some of the questions coming up a little bit more easy to understand. Okay, so 10 marks for finding all of those points, and then we're going to get another 10 marks for placing those points on our graph. Now we have to be a little bit careful placing them on this particular graph because the accuracy of the graph isn't enormous. We have gaps here that are 25 in width, and so we're trying to put in some decimal values, and we have quite wide intervals here. So we just have to be as careful as we can to place the points in the right place on the graph. Make sure to join all the dots together. Don't use a ruler to join those dots. They're not straight lines. This function is not linear. It curves up at the top and it comes back down. So just make sure we draw that freehand. And for drawing the graph, we'll get another 10 marks. So for finding the points and then placing them on the graph and connecting them up, we get a full 20 marks for that. So it's a very rewarding question, and it's important to make sure we know how to find those points correctly. The next couple of parts of the question are going to be reading information from the graph. So it says use your graph to estimate each of the following. So the first thing is the amount of drug in the bloodstream 3.5 hours after we've taken the drug. So we go to 3.5 hours on the x-axis, the axis that has time on it. So 3.5 hours is here. And then what we do is we go up until we hit the curve. And then we move across and we get a value of 200. So after 3.5 hours, there was 200 units of the drug left in our bloodstream. The next question says, how long after taking the drug will the amount of the drug in the bloodstream be 100 units? So this time we've been given the amount of units of drug in our bloodstream, which is 100. So we go to 100 on the y-axis, which is the axis that has the amount of drug. And this time we're going to go across to the right until we hit the curve and then move down to read the time. And we can see that that looks like it's approximately 1.75 hours. And 1.75 hours is 1 hour and 45 minutes. A lot of marks again for reading from the graph. We got 20 marks for finding the points and drawing the graph. We got another 5 points for part 1 and another 10 points for part 2. So the E part of the question asks us to find the rate of change of the function, the rate at which the drug amount is changing after t hours. So we can use differentiation to find the rate of change of a function. We're going to apply the power rule, which says that the powers are going to come down and multiply at the front, and then the power is going to go down by 1. So minus t cubed becomes minus 3t squared. 4.5t squared becomes 9t, and then 54t becomes 54. And so this formula now represents the rate of change of the function. Now, the rate of change will be different depending on what hour we choose. That function changed at a different rate from 0 to 9 hours. And so a subsequent part of the question will usually ask you to find that rate of change for a particular time. So part 2 of the question says, what's the rate of change after 4 hours? Now remember, we've already found that the amount of drug in the system after 4 hours is 224 units. That's not what they're asking here. Here what they're asking is, after 4 hours, what's the rate of change of the function? How fast is the drug increasing in your system after 4 hours or decreasing in your system after 4 hours? So we're going to place the 4, t equal 4, into our rate of change function rather than the original function, which represents the units of the drug in your system. So subbing 4 into this, we get that the rate of change after 4 hours is 42. And what does that mean? So what we found there is that after 4 hours, the drug amount is changing at a rate of 42 units per hour. So there was 224 units of the drug in your system, but at that particular moment in time, it was increasing by an extra 42 for every hour that went on. So E part 3 of the question asks us to find the maximum amount of drug in the system. Now it tells us to use E part 1. E part 1 was where we differentiated the function. And the reason for this is, at a maximum amount on a curve, again, we could draw a straight line across there and a tangent to that curve at that particular point. And we can see that at the maximum, the tangent to the curve has a slope of 0, or a rate of change at 0. So at that particular moment in time where the maximum occurs, the rate of change is 0. So we're going to take the rate of change that we found in E part 1. So we got minus 3t squared plus 9t plus 54. So we're going to let that rate of change equal 0. We can see that we have a quadratic equation. To make this a quadratic easier to factorize, we're going to divide across by minus 3. And we get a quadratic equation, t squared minus 3t minus 18 equals 0. We're going to factorize this quadratic to give us t minus 6 on t plus 3 equals 0. We let each bracket equal 0, so t minus 6 is equal to 0, and t plus 3 is equal to 0, and then t is equal to 6, and t is equal to minus 3. Now, we've coloured t equal to minus 3 red here, as this is an invalid solution. We can't have a negative time in a question like this. So, after 6 hours, the maximum amount of drug was in our bloodstream. Now, the question is to actually find that amount of drug. So we found the time when the maximum amount of drug is in our system, but to actually find out how much drug that is, we're going to sub that back into our original function. That tells us how much drug is in the system if we say how many hours we're looking for. So subbing t equals 6 back into the original function and tidying it up, we get that after 6 hours there was 270 units of the drug in our system. Now that was actually the highest value we had seen in our table. We had entered 6 already in an earlier part of the question. We had seen that 270 was indeed the highest amount of drug in the system. But we have to just make sure that we sub this value back in just to double check that there wasn't a higher value that we may have discounted. There may have been a decimal amount of hours that had given a higher value, and so we had to go through this procedure just to make sure that 270 units was the most amount of drug that had been in the bloodstream from 0 to 9 hours. Now note that there was only 5 marks for this, so a lot more work in a question like this. We need to differentiate the function, we need to let it equal to 0, we solve a quadratic, and even when we get our value for t, we still have to sub that back into the original. But as a question goes on and we get more and more difficult parts, sometimes we'll find that the reward for doing those parts is very low compared to some of the early parts of the question. Remember that drawing the graph and finding the points had given us 20 marks, and then all this work had only given us 5. So I suppose it's a lesson not to spend too long on some of the later parts in the question. If you are struggling with them, you can move on to the next question and then come back and maybe try and finish these sometimes later on. Okay, E part 4 says to use our answer to E part 1, so again we're using the rate of change of the drug in the bloodstream, so that's what we found in E part 1, to show that the drug amount in the bloodstream is decreasing after 7 hours. So once again, just to write down that rate of change was minus 3t squared plus 9t plus 54. After 7 hours means to sub 7 into that function. So when we do that and we tidy it up, we get minus 30. So what that value means is that after 7 hours, the amount of drug in our system is changing by minus 30 units per hour. Now minus because it's decreasing. A negative number means that the amount of drug in your system is decreasing at that stage. And for every hour at that particular moment in time, we're losing 30 units of the drug in our system. And we can confirm that by looking at the graph. Remember that the highest value in our graph occurred when the time was equal to 6. And so thereafter, after that amount of hours, the drug is on the way out of the system. We can see that the amount of the drug is decreasing. And at 7 hours, we can see that it's on the way down. And if we were to draw a tangent at the curve at the point where t is equal to 7, we can see that the slope of that tangent would be negative. And the slope of that tangent at that particular point, t equals 7, is minus 30. For every hour that goes on at that particular moment in time, the drug is decreasing in your system by 30 units. And again, we can see that the latter parts of these questions getting very few marks, only 5 marks for that particular part.